So this is going to be an extension to the previous video for trig equations. That is not the right color. Trig equations, um, but slightly more complicated. So let's jump right into it. Let's not waste any time. So let's consider something slightly more complicated, something like sine squared theta equals, let's make it 1 on 4 for now. Okay, so what happens when we have sine squared theta equals 1 on 4? So just want to point out right here that this means sine theta squared. Okay, it's not squaring the sine function, it's not squaring the theta, it's squaring sine theta. So you evaluate sine theta, then square it. So how would we undo that? We do the same thing we do with every algebra step. We figure out what it's doing to our unknown and reverse that. So it's squaring, so we're going to want to square root. So if we were to square root the left-hand side, we'd get sine theta, but whatever you do to one side, you have to do to the other, so you'd get half. And then at this point, it looks like we can just kind of continue where we started the previous video. We're like, okay, I have sine theta equals a half, so I'll solve for theta. That'll give me 30 degrees. And because now that I know all stations to central, I know sine is positive in the first and second quadrant. So I take my 30 degrees and I do 180 minus 30 degrees, and I'll get my 150 degrees. And so not too complicated in comparison to the other question. It looks like one more step. However, we have made one little mistake. What happens when you square root something? You get, I'm going to put that in red, you get a plus or a minus. You get a plus or a minus. So actually, the difference between this question and the first question in the previous video is that we have not 2 solutions, but 4. So what happens here is we need to check for, oh, wrong color again. We need to check for our quadrants again, all stations to central. It's positive here, it's positive here, but we're also looking for negative solutions. It's negative here, and it's negative here. So we should end up with 4 solutions to this equation. Oops, that went a little messy there. Okay, so how do we do that? Well, we already know the 30 degrees, so we just need to go from 180, let me just label these, 270, 360, or 0 if you like, and 90 degrees. We need to add, we have our first 30, which is in the first quadrant. We have our 150, which is in the second quadrant. We need to find the third quadrant one. So that just means adding 30 to 180, right? We want to get that total angle all the way from here, all the way around to here. So that'll just be 210, adding 180 to 30, all the way around, adding 30 to 180. And then the last angle will be in the fourth quadrant. So that'll be 360 minus 30 degrees, because we'd be going, if I was to switch colors again, we'd be going from the positive x-axis all the way around to here, all the way around to there. So that'd be 30 degrees from 360. So the one that we want, and put that in green, we'll put theta in green. So we'd want 360 minus that little 30 bit there, and that'll give us 330 degrees. And so what we'll see here is that there are 4 solutions to this specific equation. And that's because if we just had the positive version, we'd get 2. We get these 2. And if we had the negative solution, we get these 2. And so as a result, since we have both, we get 4 solutions. Okay. So if everyone's happy with that, we'll continue to another sort of quadratic, and I hope you can see that these are some sorts of these equations are sort of quadratics in the sense that they have a square involved. This is a very simple quadratic, so let's see what else we can bring up. Okay, let's consider something like sine squared theta minus 2 sine theta plus 1 equals 0. And for all of these questions I should have mentioned earlier, we're talking about a domain from 0 degrees to 360 degrees. And maybe I'll make a video on what happens if that isn't the given domain, because that's a problem as well. Okay, so let's try and mess around with this question. We'll put the solution or whatever we're doing in green. So what do we do here? Well, let's see if we can like kind of maybe, let's try to isolate. So maybe we do something like this and try to get rid of these two terms. So we move the 1 to the other side. Actually, let's move the negative 2 sine theta to the other side. So that'll become a positive 2 sine theta. Let's move the 1 to the other side. It's a positive 1. So it'll become a negative 1. And then maybe we square root that. But what you notice is, that doesn't really help because it might look like we've made sine theta the subject, but we haven't because it's still over here. So that's not the plan. Okay. What about if we, again, as we brought up before, looked at it as a quadratic? So let's make a little substitution so it looks a little, you don't have to do this, but it'll make it look a little simpler. So let u equal sine theta. And then we get something that looks like this. And this, hopefully, is a lot more familiar. In fact, it's a perfect square. So we can just immediately factorize it into something like that, can't we? You get u, if you were to expand this, you get back, right? You get this squared minus this times this, which is negative 2u, plus the square of this, which is positive 1, which is what comes up here. Okay, so we know we factorized properly. You can double check that in your time by expanding however you like. Okay, let's just solve for u here because that's the unknown. So let's square root both sides. So a little different to the previous question, not really, but when we square root one side, you do it to the other. And the result is when you square it, you get plus or minus, but plus or minus 0 is just 0, so we can ignore that. So you get u equals 1 as a solution. But hang on, that's not what we were looking for. So we need to back sub. Oh God, what happened there? So we need to sub back in what we let u equal. And we let u equal sine theta. So really sine theta equals 1. And we want to then solve for theta. So we get sine inverse of 1, which is 90 degrees. And from the previous video, we know that sine theta equals 1 has one solution, not two. But you can check that as well with all stations to central if you'd like. All stations to central, yes. 90 degrees is the base angle. Sine's also positive in the second quadrant. So you go 180 minus 90, that'll get you back to 90. So you only end up with this solution as your answer. Okay, hopefully that helped you guys. See you in the next video.